Hi everyone, in this video, we're going to explore another fundamental data type that you'll use constantly in your programming journey: strings. Strings are how we represent text in our applications, whether it's a simple word, a sentence, or an entire document. Kotlin, being a modern, pragmatic, and concise language, offers powerful and convenient ways to work with text, making your code safer and more expressive. Let's dive into the world of strings in Kotlin. A string in Kotlin represents a sequence of characters. Think of it as a collection of individual char values arranged in a specific order to form words, phrases, and any other textual data. For example, "Hello, Kotlin" is a string composed of 14 characters. In Kotlin, you declare variables using either val for read-only references or var for mutable, reassignable references. Kotlin is a statically typed language, meaning every expression's type is known at compile time. However, it also extensively uses type inference, allowing the compiler to automatically determine the type of a variable from its initial value, often letting you omit explicit type declarations. When defining a string literal, you always enclose the text in double quotes. Let's look at some examples. Example 1. Declaring a read-only string using val with type inference. Compiler infers greeting is of type string. Example 2. Declaring a mutable string using var with explicit type. Explicitly declaring message as string. Example 3. Reassigning a var string. This is allowed because message is a var. Example 4. Using special characters with escape sequences. \n for new line. \t for tab. Kotlin supports common escape sequences like \n for new line, \t for tab, \\/ for a backslash for a double quote, and $$ to escape a $sign within a string template. For strings that span multiple lines or contain special characters that you don't want to escape, Kotlin provides triple-quoted strings, also known as raw strings. These strings can contain any characters, including line breaks, without needing escape sequences, and they preserve whitespace characters. Notice how the indentation is preserved. To remove leading whitepace, you can use the .trimIndent extension function, which is particularly useful for formatted text or embedding things like HTML, XML, or JSON. Here, the character acts as a margin prefix, which trimIndent uses to determine what to trim. Traditionally, in many languages, you combine strings using the plus operator. Kotlin also supports this, but it offers a much more powerful and concise feature called string templates, or string interpolation. With string templates, you can embed variables or even full expressions directly into a string literal by prefixing them with a $$ symbol. For more complex expressions, you enclose them in curly braces after the $, dollar expression. This is equivalent to Java's string concatenation, but is more compact and just as efficient. For JVM 1.8 targets, the compiled code uses String Builder for concatenation, while JVM 9 and above compile to more efficient dynamic invocations. If you need to include a literal $sign in your string, simply escape it with a \$. Immutable objects. In Kotlin, string is essentially the same string class as in Java. Java's string objects are immutable, meaning once a string object is created, its content cannot be changed. Any operation that appears to modify a string, such as concatenation or replacement, actually creates a new string object. While a string object's content is immutable, a var variable holding a string reference can be reassigned to point to a different string object. Indexing characters. You can access individual characters within a string using the indexing operator, square brackets, similar to how you'd access elements in an array. Enhanced API with extension functions. Kotlin significantly enhances the string class with a rich set of extension functions. These are functions that add new functionality to existing classes without modifying their source code. They compile to static utility methods in Java, so there's no runtime overhead. Comparison and equality. Structural equality, =. In Kotlin, the == operator checks for structural equality, value equality, for primitive types and objects, including strings. For strings, this means it compares the actual character sequences. If both strings contain the same characters in the same order, == returns true. This behaves similarly to Java's .equals method. Referential equality, == smiley face. The == operator checks for referential equality, meaning it determines if two references point to the exact same object in memory. For string objects, this is less commonly used than structural equality, as two strings with the same content might still be different objects in memory, though the JVM often optimizes identical string literals. One of Kotlin's strongest features is its strict null safety, designed to eliminate the notorious null pointer exception, NP. By default, a string variable in Kotlin is non-nullable. This means it cannot hold a null value. If you try to assign null to a non-nullable string, your code will fail to compile. Compilation error. Null cannot be a value of a non-nullable type string. If your application logic requires a string variable to potentially hold a null value, meaning no string present, you must explicitly declare it as string with a question mark. This is a nullable string, which can be null. Can also hold a string value. When working with a nullable string, you need to handle the null case to avoid potential runtime errors. Kotlin provides several concise mechanisms for this. Safe call operator allows you to safely call methods or access properties only if the object is not null. If the object is null, the entire expression evaluates to null. Elvis operator provides a default value if the expression on its left-hand side is null. This is very handy for providing fallback values. Not null assertion operator converts any nullable type to a non-nullable type, throwing an NP if the value is actually null. Use this operator with extreme caution, only when you are absolutely certain the value won't be null, as it bypasses Kotlin's null safety guarantees. Since strings are sequences of characters, you can easily iterate over them using a for each loop. This loop effectively treats the string as a collection of char objects, allowing you to process each character individually. Okay, all right, guys. We've thoroughly explored the string data type in Kotlin. In our next video, we'll dive into Kotlin's next component. So, see you guys in the next lecture.